Hey guys, Mr. Arnold here. Again, just wanted to go over a little bit about ionic bonding, covalent bonding, bonding nomenclature, which just simply means how do we name these things. So we're going to just focus on ionic bonding and how we get the bonds, and then what is the chemical formula, and then how we actually name the actual element or chemical itself. So ionic bonding is when we have bonding happening between a positive ion and a negative ion. And again, we've talked about this before. This is the cat ion, and this is the anion. So these are typically our metals. They like to donate their electrons because they have very few valence electrons. So they like to drop down to the next lowest level. The anions are typically our nonmetals. They like to accept the electrons, and they actually have many valence electrons. So by accepting a couple of more, they can get to their lovely happy number of 8, which hopefully by now has been drilled into your head enough times. 8 is the magical number when it comes to bonding. Earlier I showed you guys the sodium and chlorine atom, and we'll just kind of quickly go over that, and I'm going to try to change up some colors here, so bear with me. And again, I'm going to use X's for the one, and I'm going to use little dots for the other one. These are supposed to be Lewis dot diagrams, and we explained in the previous video that sodium has a total of 11 electrons. 2 of them can go on the first level. That leaves 8 to go on the next level, which is 10, which means there's only 1 left on the outside level. Sodium has 1. It can either try to pick up 7 electrons to get to the magic number of 8, or it can try to get rid of its 1, and it actually is going to get rid of its 1. So when it gets rid of 1 electron, it now becomes slightly positive. Chlorine likes to take on 1 because it has 7. It only needs 8 to get up to that next level, so chlorine likes to take on that extra electron. The positiveness of the sodium atom with the negativeness of the chlorine atom is the actual bonding force that holds those two together. We know that if we take 2 opposite charges, they like to attract. If we have 2 of the same charges, they like to repel. So because we are positive and negative, we are now going to be attracted together. And because we're only using 1 of each substance, it's literally just NaCl, which is sodium chloride. And I explained a little bit, and I'll explain more as we move on. All you do is state the first element, which is always going to be your positive element, sodium. You state your second element, which is always going to be your anion or your negative ion, and that is going to be chlorine, but instead of using the INE ending of chlorine to show that it is bonded, we simply say chloride. And an IDE ending is telling you that there is a chemical bond that has happened. Again, remember, once these two bond together, they lose all of their properties. Sodium is a reactive metal. Chlorine is a deadly gas. When you put those two together, they become salt, which is needed by our bodies to be able to function properly. There we go. Let's do another one here just so you guys can kind of see what's going on. Again, changing some colors out, hopefully making it easier to see what's going on. Let's take a look at lithium. Lithium is in the second family. Lithium has 4 total electrons, 2 on the first level, which means it has 2 on the outer level. Hold on here. Hang on one second. Let me erase that here because I just totally said that wrong. Not lithium. I didn't want lithium. I wanted beryllium. That was my bad. So beryllium, Be, has 4 electrons. It has 2 on the inner level, and it only has 1 or 2 on the inner level, and then leaves 2 for the outer level. So we're going to take beryllium, and we are going to bond it with, let's see here, oxygen. Oxygen has a total of 8 electrons. That means it has 2 on the first level, and it only has 6 on the outer level. So the number of valence electrons are 6. Well, beryllium would love to get rid of its 2, so it's going to donate 1 right there, and it's going to donate its other one over here. So lithium has gotten rid of its 2. It now has a 2 positive charge because it got rid of 2 electrons. Oxygen has taken on 2, so it now has a 2 negative charge. And so if we take a look at that, the net result, 2 minus 2, is 0. So when the net charge equals 0, now you have a stable bond. And this is simply BeO, which is beryllium oxide. Again, dropping the ending of oxygen and just adding the IDE portion to that. What happens if we have something like, we'll use lithium this time, that only has 1, and let's use oxygen again, since we know it, it has 6. How does this one work now? Lithium gladly gives up its 1. It has a positive 1 charge now. It's happy, but oxygen still has an issue. What do we do over here on the other side? Well, we have to bring in another lithium atom. We can add as many atoms as we need. We just simply cannot take away atoms according to the law of conservation of mass. So lithium comes in, another lithium, and donates its electron. Again, it's positive 1. Oxygen has now picked up its 2 electrons. It's now negative 1. So the net charge, 1 plus 1 minus 2, is still 0. So the overall net charge is balanced out. We now have 2 lithium atoms and 1 oxygen atom. And if you notice how I wrote that, I put a little 2 subscript at the bottom. That shows you that you need to have 2 lithium atoms to balance out 1 oxygen atom. So when you see something like MgCl2, that 2 tells you you need 2 of these negative 1 charges to balance out the 1 positive 2 charge. So that's we call those subscripts. That tells you exactly the number that you need in the chemical formula. And again, this one would be magnesium. You always keep the positive ion the same. You don't change its name. And then we talked about chlorine already. It's not chlorine, it's chloride. Again, that's how we name. We take the metal name, the positive ion first. We always leave it the same. We then take the last few letters of the non-metal or the negative ion, and we drop that and add an IDE ending. So when we talk about ionic bonding, you'll notice that you'll see a bunch of sodium chlorides and magnesium fluorides and things like that. Those are all showing you ionic bonding. And that happens because we have ions, positive and negative ions. Again, over here, we had our positive ions trying to help stabilize or cancel out our negative ion. That's about as complicated as it gets with ionic bonding. As always, if you got any questions, let me know. See you.